Hello, this is Ian Harper welcoming you to Business of Weather podcast, produced in association with Asia Climate Forum, Asia's largest event dedicated to extreme weather and climate change, flooding and poor air quality. In each episode, we'll investigate the increasing impact of extreme weather and climate change on business and society, and look at how weather technology and climate information services can help address the growing challenges. We'll also spotlight the new opportunities for entrepreneurs and business startups seeking to develop the business potential of technology innovations to help those affected by extreme weather. LIDAR, short for laser detection and ranging, is a surveying technology which combines 3D scanning and laser scanning. It's a versatile tool that measures the distance to a target by illuminating the target with laser light and then measuring the reflected light with a sensor. Applications range from pollution monitoring, agriculture and archaeology, the digital mapping of building interiors, wind farm optimization, and guiding autonomous vehicles. One leading player in the development and use of LIDAR technology is the Greek company Raymetrics. Business of Weather spoke to the company's founder, CEO and chairman, Nikos Kontos, about the company and some of the applications of LIDAR technology. Welcome, Nikos.
Hello, Ian.
Right, now, tell me about Raymetrics. When was it founded? How did you fund it? What is its main business? And how big is it now?
Okay, Raymetrics has been in operation since 2002. Making us probably the first atmospheric LiDAR company in the world. Back then, the only people using aerosol LiDARs were researchers. We therefore come from a background in LiDAR science, and to this day, we maintain strong links with the academic community. Over the last 17 years, we have developed a range of highly customizable products suitable for academic uses and commercial uses as well, such as aviation, mining, heavy industry, and operational uses such as meteorology, environmental, etc. Our LiDARs are located all over the world with systems in the USA, India, China, Africa, Brazil, Singapore, Indonesia, Germany, and UK, of course. Over the years, the company has built up an extensive client list, which includes prestigious organizations such as Met Office in UK, European Space Agency, National Environment Agency in Singapore, the German Weather Service, etc. The product portfolio comprises standardized vertical profiling and standardized 3D scanning LiDARs with the ability to combine new technology with existing systems such as radars. In addition, Raymetrics offers customization for all its LiDAR systems, as well as installation, systems integration, maintenance, services, and training for new and existing customers. Raymetrics right now employs directly 25 people and indirect over 100, and it produces over 3 million euros in sales.
Right. How do you go about setting up the business? What sort of encouraged you to set up the business in the first place?
Well, the company existed on a university, let's say, basis, and we felt that this technology would be the future in remote sensing. So we decided, myself and a fund, to raise money and to get involved through an equity participation. So that was the beginning of this journey.
So it was very much putting what you thought was a good idea into practice.
Exactly.
Okay. Now, one area you focus on now is air pollution monitoring using LIDAR technology. What exactly is LIDAR and how does it work?
Okay. LIDAR stands for light detection and ranging. The technology works by emitting a pulsed beam of light from a laser into the atmosphere. The particles in the atmosphere scatter the laser light, some of which is returned, backscattered, to a telescope. The time taken for the light to be returned can provide the distance of targeted particle layers, the ranging part of LIDAR. LIDAR is a remote sensing technique, meaning that the systems measure the composition of the atmosphere over large distances, from several hundred meters up to several tens of kilometers. As there are currently very few techniques for remote measurement of the atmosphere, LIDAR is becoming increasingly important on a global scale.
Okay, so what types of information can LIDAR provide when it comes to monitoring atmospheric pollution?
Depending on the complexity and specifications of the system, the properties of the backscattered light can also provide information about the particles in the atmosphere. This can include particle types, water, ice, cloud determination, volcanic ash, and natural man-made dust differentiation, fire smoke identification, and other things. All the above are related to particulate matter emissions, commonly known as PM10 and PM2.5.
Right, can it actually help analyze the nature of the atmospheric pollution and possibly track where it might come from?
Yeah. This is one of the key factors, the key facts, I would say, of the technology and the product dedicated for that. What our LiDAR can provide is identification and mapping of all possible PM sources related real-time remote pollution monitoring.
Okay, now, who are the customers for this type of application?
Perfect. The customers would be national environmental agencies, big industries, mining companies, could be also civil aviation authorities, and of course, private sector working on a health risk assessment.
Now, urban pollution is an increasingly big issue. Is LIDAR a good tool for monitoring, forecasting, and warning about pollution in the urban environment, for example, from cars or other vehicles?
Okay, Ian, our new PMI LiDAR is an ideal tool for urban pollution monitoring. This product offers wide coverage. A single LiDAR can cover 5 kilometers square area and identify all PM sources, practically locate the hotspots of emissions. 3D monitoring. LiDAR is the only technology that can monitor horizontal and vertical PM dispersion. High sensitivity. LiDARs in general are highly sensitive to PM particles and can identify them even when they are not visible by eye or a video camera. And last but not least, real-time information. All data are provided in real time, giving a good understanding of the temporal behavior of the PM productions.
Okay, now, I understand you have a LiDAR system installed in Singapore. What is that being used for?
That is correct, Ian. It is a 3D scanning LiDAR operated by the local National Environmental Agency called NEA, N-E-A. The main application is for pollution monitoring and monitoring incoming phenomena like fog or haze coming from Indonesian fires, volcanic ash, etc.
Right, okay. Now, how long has it been installed in Singapore?
2 years now.
Now, aside from air pollution monitoring, what other applications are there for LiDAR systems?
Okay, and there are a lot of other applications. The LiDAR technique is very well known to the market since many years now and has been proven to work in various sectors. Raymetrics systems cover all relevant areas of meteorological measurements, such as atmospheric profiling, cloud detection, planetary boundary layer studies, remote air quality data measurements, such as validation of climate and weather models, volcanic gas, dust, fire smoke detection, vertical visibility, temperature, and humidity measurements. In addition, we can offer comprehensive solutions for civil aviation authorities, airports, as well as meteorological agencies. We do have a multi-purpose system that covers several applications, such as providing slant visual range, 3D cloud-based measurements, fog bank detection, forecasting, as well as early warning for anomalies such as volcanic gas, extensive dust or smoke. I would add another two applications, fire detection. Raymetrics systems provided real-time data indicating the emergence of fires and other natural phenomena and distribute the results to the connected authorities, ensuring quick response times and targeted countermeasures. And also, I would add oil spill detection, where we are able to produce a product utilizing the LIDAR-induced fluorescence technique designed to scan the surface of the sea for detection of oil spills.
Interesting. Now, where do you see the major growth areas and applications for LIDAR over the coming next few years?
Well, the LIDAR technique is very well known to the market since many years now. And as I mentioned to you earlier, it has been proven to work in various sectors. Of course, autonomous vehicles are a very big market. But additionally, I would add to that that LIDAR can be used also for precision agriculture by developing agricultural strategies to secure sustainable food security under climate change. I would add also autonomous vessel technology, LIDAR sensor systems for autonomous and remote navigation. Another sector could be also biological warfare and CBRN monitoring. LIDAR systems can be used to detect a variety of chemical and biological agents. And of course, current issues including water and air pollution, as well as climate change, are the main reason for the emergence, let's say, and need for environmental monitoring.
Right. Now, that brings me to my final question. I understand that, as you mentioned, a big and growing application for LIDAR is going to be in guiding autonomous vehicles, the use of which is predicted to grow rapidly over the next few years. Can you tell me more about this type of application for LIDAR? And is this an area you're interested in?
Okay, Ian, let me say that this is an area that we are far away of because we are building, as I explained to you, atmospheric LIDARs. The technique it's similar but not the same. It needs a lot of research, R&D, and development. So to answer your question, for the time being, we are not interested to get into this technology, since, as I mentioned, is it too far away from what we do. But I cannot say that for the near future. Maybe that would be a case for investing.
What about these other areas you mentioned, like precision agriculture?
Well, yes, there we are building a new LIDAR. We're calling this LIDAR humidity and temperature LIDAR. That measures the profile of humidity and temperature up to 20 kilometers in the atmosphere. So this LIDAR could give us a lot of help by measuring humidity and temperature in big agricultural areas. That would also help to produce better models for much better weather forecasting. So this is a very, very good product to increase, let's say, the sensitivities of the model and having a better nowcasting and forecasting, weather forecasting.
Okay, well, look, thank you very much. That concludes our interview today. Nikos Kontos, Chairman and CEO of Raymetrics, thank you for your time.
Thank you very much, Ian. Thank you very much.
You're listening to Business of Weather, produced in association with Asia Climate Forum, Asia's largest event dedicated to addressing climate change, flooding, and poor air quality.